Okay, so what we're going to work on today is doing the inverse of an exponential equation. All right, so let's take a look at the try this. And it says find the inverse of f of x is equal to x plus 4. So remember, inverse is a reflection over the line y equals x. And hopefully you'll remember the rule is when you flip it over the line y equals x, xy becomes y x, right? So that rule is to switch x and y. All right, so here is my y equals x plus 4. I'm going to switch x and y. X equals y plus 4 minus 4. Y is equal to x minus 4, and that's my inverse. So the inverse of f of x is equal to x minus 4. All right, so now we're going to do the inverse for an exponential. So remember, another thing I would like you to remember is that when you do the inverse, and I said that the inverse is a reflection over the line y equals x. Hopefully remember, if you don't remember what y equals x looks like, you could graph it on your calculator. It looks like this. It's the one right on the diagonal. So if I have a point over here, on the top left, and I flip it over the line, it would end up over here. Okay, so that's what I'm going to be doing. I'm reflecting an exponential over the line y equals x. So the first thing we're going to do is we are going to graph f of x is equal to 2 to the x power. And then I also want you to graph y is equal to x. So over here on the side, I'm going to make a table of values. So here's your f of x or your y value. All right, so we're going to go from -3, -2, -1, 0, 1, 2, 3. And if you could take out your notes from before to get those values, or you can plug it into your calculator. So if you don't have your calculator in front of you, put me on pause, get your calculator. All right, so we have at -3, y is 0.125. At -2, y is 0.25. When x is -1, my y is 0.5. When x is 0, my y is 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, my y value is 8. Okay, so now let's graph that. Okay, so it'll look like this. Okay, so remember your x-axis, that's your asymptote, which means that my graph gets closer and closer to the x-axis but won't ever touch it or ever cross it. Okay, so graph the line y equals x. That's the one that's right on the diagonal like this. Okay, so now we're going to take this exponential here, and we're going to flip it over this line y equals x. So now to make my graph a little bit more accurate so I don't draw anything too shabby, okay, I'm going to make that x and y. I'm going to take these values here and I'm going to switch it. So 0.125 now becomes my x. So 0.125 and my y is -3. Remember, I'm switching x and y. So 0.25, -2. 0.5, -1. 1, 0. 2, 1. 4, 2, and 8, 3. Okay, so plot the points. So I have, on my x-axis is 0.125, so it's really close to 0 and down to -3. So it's close to the y-axis, but not on the y-axis. And then I have 0.25 at -2. And then I have 1, 0, 2, 1, 4, 2, and 8, 3. So it'll look like this. Kind of like that. Sorry, not so pointed in here. Let me do that better. Sorry. So it'll look like that. So that's your inverse there. All right, so Remember, now let's talk about the equation. And so that kind of makes sense. If I take this guy and I flip it over this line, it'll end up over here. Notice it went through 0, 1. Now it goes through 1, 0. Okay, so let's take a look at the equation. Here's my f of x is equal to the x power. And I'm going to flip it over the line y equals x. So remember, the rule is xy becomes y x. So I'm going to take f of x and make it y equals 2 to the x power. And now I'm going to switch x and y, and I get x equals 2 to the y power. All right, and then before we talk about that again, remember I said back when we were doing graphing exponentials, I told you about base e. So remember we graphed y is equal to, or it was actually f of x is equal to e to the x power. So the inverse would be x is equal to e to the y power. All right, so now what's wrong with this equation here? Well, what's wrong with it is that we don't like things in x equals form. We like things in y equals form. So when I have this equation, x is equal to 2 to the y power, to put it in y equals form, I use logarithms. Okay, so it's y equals log base 2 of x. So the y, this guy here, is your exponent. Okay, so it came from here. The 2 is your base. So I always tell the kids, your base is always your base. Your base is here. That's your base. That did not change. Base is base. And this x here, that number that goes there, is what it's equal to. That's from here. Okay, so these kind of like change positions. What's with the 2 is now on the other side, and what's on the other side is now goes with the 2, and you put a log with it. All right, and you would read this as y is the logarithmic that's a C, to base 2 of x. All right, so what a log is the inverse of an exponential. All right, so your general form for a log, so here's my general form, x is equal to b to the y power. So I'm talking about general form like a line is y equals mx plus b. We talked about the equation of parabolas. So this is your log form. So I have what it's equal to, and I have the exponents. So remember, these kind of like switch. So now it's y equals, then I put in log. My base is b. So that's like shifted. When I write my base, it's shifted down. It's not even with the word log. It's shifted down and it's written a little bit smaller. Log base b of x. All right, now let's just take a look at the natural base e. So it's the same thing. So I would write y equals log base e of x. However, we don't normally write something that has a base e with a log. So how we would write this is y equals ln, that's called the natural log, ln x. Okay, so this is called the natural log. So when you see ln, you have to know that that's base e because we don't write base e. You have to know that. Okay, so flip over your paper. I got to change screens too. Okay, so now what I need you guys to be able to do is to be able to switch from an exponential form. So here's your inverse. I want you to be able to switch from your exponential form to your log form. You have to be able to switch back and forth. Okay, so my exponent is an a, so that is now my equals. So a equals log. What's my base? My base is 12, base 12, written a little bit smaller and moved down, of b. So a equals log base 12 of b. All right, let's try the next one. So here's my exponent. right? These now switch. It equals 2, so now it's going to equal 1/2. So 1/2 equals log base 4 of 2. All right, let's look at the next one. X equals 5 to the x to the third power. All right, so now I'm going to start off with writing log. So it's going to be log base 5. Now remember, these switch. Base 5 of x equals 3. So all I did was rewrite it around the other way. Okay, just switched around the equal sign. So you make sure you can write it both ways. All right, don't get just used to writing it as the equals first. Okay, you get used to writing as log first also. All right, and the last one, 16 equals x to the second power. So it's log base x of 16, because remember they switch. What's with the x now goes to the equals, and your equals now goes to the x, of 16 equals 2. Okay, so that's put in log form. All right, now you want to be able to take your inverse, which is in your log form, and take it out of log form and have your inverse written in exponential form. Okay, so now it's going the other way. So what's my base? My base is 2, and then these two are going to switch back. So it's 2 to the 5th power is equal to 32. All right, let's look at the next one. Log base 3 of 27 is equal to 3. So my base is 3, so it's 3. Now these two switch. To the third is equal to 27. All right, number 3. Log base 10 of 1 over 100 equals negative 2. So my base is 10. It's 10 to the negative 2 power is equal to 1 over 100. And the last one, log base 3 of 1 equals 0. So my base is 3. 3, switch them, to the 0 power is equal to 1. Okay, so now let's take a look at the last couple of problems. All right, it says to solve for the unknown. So remember, in class I said that that your logs and your exponentials, they go together, and your exponential rules will always come back, your exponent rules, will always come back into logs. All right, so let's take a look at this. It says solve for the unknown. When you have it in a log form, you want to take it out of log form and put in exponential form. So let's write that down. Put in exponential form. Okay, so I have log, let's look at the first one. Log base 7 of x equals 0. So my base is 7. So it's 7, remember these two switch, to the 0 power equals x. All right, well, what's anything to the 0 power? Right, so 7 to the 0 power is equal to 1. If you're not sure, plug it in your calculator. All right, next one. Log base 81 of x is equal to 1/2. So my base is 81, so it's 81, switch x and 1/2 to the 1/2 power equals x. So you could, of course, plug this into your calculator. But remember, when you have a 1/2 power, we could also do power over the root. So this means, and you should know this just off the top of your head, that when you have an exponent that's a 1/2 power, that's always the square root. So this is the square root of 81. So x is equal to 9. All right, next one. Log base 8 of 32 is equal to x. So my base is 8. These two switch. X to the 8 to the x power equals 32. So remember, to solve these, what we do is get the bases to be the same. So can you write 32 with a base of 8? Remember, you can never go from a small base up to a large base, only from a large base down. So can I write 32 with a base of 8? So 32 to the first? No, that's 8. 32 to the second? No, that's 64. So when you can't do that, you have to change both. Oh, what was that? Sorry, pressed the wrong thing. All right, so let me move that up. Let's write 8 a different way. So I have 2 to the third power, that's equal to 8. Remember, you have to raise 8 to the x power. What's another way to write 32 with the base of 2? 2 to the 5th power is 32. This over here becomes 2 to the 3x, remember power to a power, equals 2 to the 5th. Set the exponents equal, 3x equals 5. Divide by 3, x is equal to 5/3. All right, and the last one, we have log of x, log base x of 125 equals 3 over 2. So my base is x, so it is x to the 3/2 power equals 125. So remember, to solve this, I want to get rid of the exponent that is here. So I multiply the exponent by its reciprocal. It's multiplicative inverse, which is 2/3. Do the same thing to the other side. X equals, just plug this into the calculator, 125 to the 2/3 power, and that is equal to 5. Okay, so that's it, and we'll practice more in class tomorrow. Have a good night.